Alright, so this is question 5. Question 5 states, two particles move along the x-axis. For t is greater than or equal to 0 or less than or equal to 8, the position of particle p at any time t is given by xp of t, which is ln natural log of t squared minus 2t plus 10. While the velocity of the particle q at time t is given by vq of t, which is t squared minus 8t plus 15. Particle q is at position x at time t equals 0. So before I even start, what I did is I wrote down both of the functions they gave me. But in addition to doing this, I found either, for q, I found the position function, and I found the velocity function for particle p. To find the velocity, you simply just take the derivative function for natural logs. If it's ln of u, the derivative goes to 1 over u times the derivative of u itself. So it's 1 over t squared minus 2t plus 10 times the derivative of this, which is 2t minus 2. So simply it's 2t minus 2 over t squared minus 2t plus 10. For the velocity function which we were given, you simply take the antiderivative. There are many ways to do this. I use the inverse chain rule. And you have to remember to add 5 because it says particle q is at position x equals 5 at time t equals 0. So that's why I have it there in green. Alright, so part A asks, for the interval given, when is particle p moving to the left? So I simply think when particle p is moving to the left, that means the velocity is going to be negative. So you take this and you find out where 2t minus 2 is going to be negative or positive. T squared minus, originally you would do both, but t squared minus 2t plus 10 never is negative, it's always positive in the interval given. So simply, I used the outer bounds 0 and 8, and I know that 1 makes this 0. So in between, from 0 to 1, it's going to be negative, and from 1 to 8, it's going to be positive. And you can, personally, I just plugged in points. You could plug in as many as you want just to make sure. But since it's negative from 0 to 1, you know that particle p is moving to the left when x is greater than or equal to 0 or less than or equal to 1, because the velocity of p is less than 0 in that interval. Now B asks, for the interval given, find all times t during which the two particles are in the same direction. So we know when particle p is moving to the left, moving to the right, given that. So basically that's all we have to do for particle q. So particle q, when simplified, is t minus 3 times t minus 5. So what I did was I made another one of these sign charts from 0 and 8 as my outer bounds and 3 and 5 as my inner bounds because those make it as 0. And I just plugged in points again and found that 0 to 3 is going to be positive, 3 to 5 is going to be negative, and 5 to 8 is going to be positive. And then I compared the charts and I just saw when it was going to be positive. So I found that between 1 and 3 and 5 and 8, they're both going to have the same signs. And my explanation for that was because their velocities are going to have the same signs. Alright, so for C, it says find the acceleration of particle q at time t equals 2. Is the speed of the particle q increasing, decreasing, or neither at time t equals 2? Explain your reasoning. So what I did was I found the acceleration formula for particle q. So what you do is just take the derivative of the velocity, so it would be 2t minus 8, and then I simply just plugged in 2, and you get negative 4. But we're not done there. We also have to find the velocity of particle q to see if it's increasing, decreasing, or staying the same. So simply you plug in 2 again, and you get 3. Now since these are different, that means that particle q is actually decreasing in speed. Because if its speed's 3 and its acceleration, which is the change in speed, is negative 4, that means it's going slower than it was before. So that means it's decreasing. And your explanation for that is because velocity of 2 Q's velocity at 2 and Q's acceleration at 2 have opposite signs. D asks, find the position of particle Q the first time it changes direction. So we already know what the position graph is, or position function is. It's 1/3 t cubed minus 4t squared plus 15t plus 5. And we already know that it changes position first since we closed it or drew the sign chart here. It changes position at 3. So all we have to do is plug in 3 into the position function. And you get 23. So particle Q changes first direction when t equals 3, and its position is 23 units. All right, and that's the end of question 5.